In this video, I'm going to talk about the mean value theorem. Okay, so mean value theorem is still under section 3.2 of the book. So I had the previous video, that is the Rolle's theorem, and this video will talk about the mean value theorem. Okay, what does it say? If a function f is continuous on the closed interval ab and differentiable on the open interval ab, then there exists a number c in AB such that f prime of c, it is slope of the tangent at the point c, at the number c, is equals to fb minus fa over b minus a. What is that? This is basically, this is bfb, this point is bfb, this point is afa, right? Because you see that point is bfb and that point is afa. So that point is AFA, this point is BFB. So what is the slope of the line joining this point and that point is FB minus FA. So y2 minus y1 over x2 minus x1. So that's the slope, right? What does it say? It's basically, so if a function is continuous in the closed interval AV and differentiable in the open interval AV, then you will be able to find out a point C between A and B such that the slope of the tangent line, or the tangent line at the point C, is parallel to the secant line joining that, because the slope is equals to the slope of the secant line, right, joining the endpoints basically. So this is in other words, you can see that if f is continuous on the closed interval AV and if f is differentiable in the open interval AV, then you will be able to find out a point C between A and B where the slope of the tangent is equal to the slope of the secant line joining the endpoints. That's what it says, right? Slope of the tangent line at C, that's C, right, is equals to the slope of the secant line joining the endpoints. In other words, this is basically, this will give you the average velocity, right? This is the instantaneous velocity, this is the average velocity. So if you want to describe that way, then it will be like, if a function is continuous in a closed interval and differentiable in the open interval, then you can say that, then you will be able to find out a point between A and B where the instantaneous velocity is equals to the average velocity in that interval. That's fine. So that's another way of saying that, okay? So, but there is at least one point C. There may be more than one point C between A and B, that's so that the slope of the tangent is equals to the slope of the secant line joining the endpoints. Let us look at this example. So the fx is that black color curve, okay? So what is the secant line joining the endpoints? This is one endpoint, this is another endpoint. I join that, that's the secant line. Okay, the function is continuous everywhere. The function is differentiable everywhere because there is no sat corner or cusp, anything there in both cases, right? So we will be able to find out at least one point C where the slope of the tangent line is, or the tangent line is parallel to the line joining the endpoints, right? Or the secant line joining the endpoints. Look at this. This is one point C. Here, the tangent at the point C is parallel to that, and there is another point C, I denoted by C1 and C2, where the tangent line is parallel to the secant line. Okay, that's what the mean value theorem says. Okay, let us do some examples, then it will be clear for you. Determine if the mean value theorem can be applied to fx equals to x plus 5 over x minus 2. What is given is f of x equals to given as x plus 5 over x minus 2. The interval is -8 to 8. Do you think this function is continuous in at all the points between -8 and 8, including -8 and 8? The answer is no. Why? Because if you solve the denominator here, then at x equals to 2, the function does not define, right? At x equals to, the function is not defined. Since the function is not defined, there is a break. It is not continuous. So how do you write that? Since f of x is undefined at x equals to 2, because there is a 0 in the denominator. For x equals 2, there will be 0 in the denominator. That means it is infinity. The overall fraction will be infinity, right? So f of x is not continuous at x equals to 2, but the mean value theorem says that it must be continuous at all points between A and B. So hence the mean value theorem we denote by MVT, mean value theorem, is not applicable in the interval -8 to 8. If it was peak, like if it was 4 to 8, it would be applicable though. But in -8 to 8, it is not applicable. So the answer is no. Okay. So if yes, find C, but it is no, right? So C is not available, not applicable. Since the Rolle's theorem is not applicable, so there is no such C, not available. Okay. Let us do another example. Determine if mean value theorem can be applied for fx equals to 5 cosine x on the interval 0 to pi. If yes, find C. So what is fx? So f of x is equals to 5 cosine of x. So this function is continuous everywhere. This function is, oh, by the way, I forgot to give the, oh, there is interval on 0 to pi. So the function cosine x is differentiable everywhere. The function cosine x is continuous everywhere. So we are okay to use the mean value theorem. Then continuous and differentiable everywhere. So it will be continuous and differentiable on this interval too. So by the mean value theorem, you can write f prime of C equals to f of pi minus f at 0 over pi minus 0, right? So what does this imply? What is fx is 5 cosine x. What will be f prime of C? So the f prime here basically, so f prime of x will be -5 sine x, right? So what is f prime of C? That will be -5 cosine C, -5 sine C equals to, what is f at pi? F at pi is, you replace x by pi. 5 cosine pi is -1, so it will be -5 minus f at 0. If you replace x by 0, you will get 5 cosine 0 is just 5. Divide by pi minus 0, right? So what do you get? Basically, you got, it is -10 over pi. You see that? So what do you get? You got -5 sine C equals to -10 over pi. So what I'm trying to do is I'm dividing by -5. Let's do that. Divide by -5. Divide by -5. What do you get? You got sine C equals to 2 over pi, right? So you'll get, this implies, let me start here. Sine C equals to 2 over pi. So how do you solve for C? You take sine, arc sine on both sides, right? So C equals to arc sine, or you can do inverse sine. Arc sine 2 over pi. So if I use calculator, I will get C equals to 0.69, 0.69 and then 0.1. This is what I get. Okay, let's talk about a note here. For a function fx, the value fb minus fa over b minus a is the average rate of change. Okay, this is also called the average rate of change. Okay, average rate of change in the interval AB. If st, instead of using f, if you use st is the distance of a moving object, distance function for a moving object, then the average rate of change, or we call average velocity. Okay, average velocity. Okay, I can denote by av. Average velocity is given by sb minus sa over b minus a. So let us do an example for that. Basically what I am saying here is, as I mentioned already, if a function is continuous in the closed interval and the differentiable in the open interval, then you can find a point where the instantaneous rate of change or the instantaneous velocity is equals to the average velocity, okay, in that interval. So let's do this example. The height of a falling object after t seconds is given by st equals to -4t square plus 390. So the question number A says that find the average velocity during the first 2 seconds. So what is the formula for average velocity? So average velocity is equals to SB. So what is the 2 seconds? 2 seconds is basically 0 to 2, right? The first 2 seconds means 0 to 2. So what I do is S2 minus S0 over 2 minus 0, right? What will be S2? You just replace T by 2. What do you get? If you replace T by 2, you'll get negative 4 times 4, right? Because 2 square will be 4. And then plus 390. So that will give you 370.4. So if you use calculator, so 370.4 minus, it will be S0. What will be S0? S0 will be just replace T by 0, will be just 390, right? 390 divided by 2. If you use calculator, you will get negative 9.8 meter per second. This is the average velocity you get. Okay. Now the next thing what you do here is use the mean value theorem to verify that at the same time during 0 to 2, at some time during 0 to 2 seconds, the average velocity is equal to the instantaneous velocity. Basically, you want to find out C here. Okay. So since so what I should say here is S of t is continuous on 0 to 2 and differentiable on 0 to 2, then by mean value theorem, there exists a C, so that S prime of C is equals to S of 2 minus S of 0. I'm just using this exact same procedure, right? 2 minus 0. What do you get? This implies, by the way, I had a typo here. It is not negative 4 t square. It is negative 4.9 t square. Okay, negative 4.9 t square. So in that way, you will get 370.4. Otherwise, you don't get that. Okay. The first derivative of this will be 2t. The t square will be 2t times negative 4.9 will be negative 9.8 t. But you are trying to find out at c, right? So it will be negative 9.8 c is equals to, what did you get this value? We find out that already, negative 9.8. This is what you got. Now divide both side by, if you divide both side by negative 9.8, what do you get? Negative 9.8, negative 9.8. Basically, you got C equals to 1, right? Because you cancel out those. So at C equals to 1, the average velocity is equals to the instantaneous velocity. Or what that means is after the 1 second, at 1 second, then the instantaneous velocity is equals to the average velocity. So let us look at the last example. What it says is you need to find a function fx, or you say y, whose derivative is given and that pass through the point 0, 4. So it is very easy problem, right? Because if one point is given and if the derivative is given, basically derivative is the slope, right? So what is the equation of the tangent line, or the equation of the line? So it is basically y minus y1 equals to m times x minus x1, right? So so I will do this problem actually two different ways. Y minus y1 equals to m x minus x1. So what do you get? You get y minus y1 is 4 equals to 3 x minus 0, right? So what do you get? Y minus 4 equals to 3x. Add 4. What do you get is y equals to 3x plus 4. So the function fx is basically 3x plus 4. So this is one way of doing that. Let me do alternative way too. Alternative. So although you don't know the entire derivative, you will see that entire derivative in chapter 4, right? So what is given is f prime of x is given as 3. So can you tell me a function whose derivative is 3? So you can think like this, right? F of x maybe like this, 3 and then x plus a constant k. What is the derivative of this function? It is 3, right? So that's why I just assume that since the derivative is 3, the function must be like 3 times x. If you find the derivative of x, it will be 1. So 3x plus a constant. It may be 1, 2, 5, 10, 100 like that, right? But what is given there is, when x equals to 0, y is given as 4, right? You use that. So what you get is 4 is equals to 3 times 0 plus k. So what do you get? K is basically 4, right? Because 3 times 0 is 0. Now you plug in back to fx. Therefore, f of x equals to 3x plus 4. So either way is okay. But in chapter 4 you will learn how to find the antiderivative of this kind of functions, and then basically this is what we do, but there is a formula to find out the antiderivative. Okay guys, thank you.